In this section, we will analyze the life cycle of a thread. The automata we represented in this figure represents the states a given thread can assume during the time. We will describe each of them in details in the following. Well, first of all, the initial state. The initial state is the starting state of the thread life cycle. A thread is in its initial state after we have created it and before it is started. It's very important to notice that a thread in its initial state is not alive. Okay, what happens when the start method is invoked? Well, simple. We move to a new state, namely the runnable state. A thread in its runnable state is waiting for a turn on the CPU to execute it. The thread is really alive and can move from runnable state to running state when the CPU is allocated. When the operating system scheduler selects the thread among available ones to be executed, well, the thread moves from runnable state to running state. A thread is in a running state is executing and is associated with a time slice. The time slice is a time where the thread is allowed to access the CPU and to use the CPU to progress in its execution. Of course, the running state is a state where a thread cannot stay forever. Otherwise, it would use and exhaust all the resources of the operating system, of the CPU, and this would have an impact on the overall system performance. So a system in running state, after its time slice, will move back to the running state, to the runnable state, or if in case it's blocked, waiting for some resource, or waiting for some event to occur, we will see this later in this class, it may move to the blocked state. Or finally, in the case it terminates its execution, it may move to the finish state. A thread is in block state if it is waiting for resources held by another thread, or if it is waiting for results of a I/O operation. We will understand better the block state and how to block a thread in future lectures of this class. So, a bit of patience and everything will be extremely clear. For now, it's important to notice that it's possible to block a thread and that the thread could be unblocked due to some event. Okay? What happened? Okay, of course, you cannot have a thread blocked forever. This would be a problem. It means that there's a flaw in your software. So the block state is something temporary. And after a thread is blocked, it can transition to the runnable state, meaning that you can the event, the resources it is waiting for is available, and so the thread can progress in its execution. So it's available, it's runnable, can be scheduled to progress with the logic. Okay, so very, very simple. Then we have the finish state. A thread is in its finished state when completed the execution of the run method, or when it terminates due to an unhandled exception. So these are the reasons. let me notice that a thread, once it's finished, cannot be restarted again. So you need to create or to run a new instance of the thread. Let's have a recap of what we have discussed. Basically, we described the life cycle of a thread. The life cycle is very simple. When we create a new thread, it is in initial state, then it can transition to the runnable state whenever the start method is invoked. A thread in runnable state is available, can run, is in a pool of runnable thread, of thread that are competing for the CPU. When the scheduler scheduled the thread to run for a specified time slice on a CPU, the thread transitions to the running state. The thread stays in its running state as long as its time slice expires, or when it encounters some instruction that causes it to block. Examples are synchronization or I/O instruction. If you are in a block state, you stay there until some event occurs that makes it possible for you to progress. So when you finish your I/O operation, when the synchronization operation enable you to access resources that are held by other thread, you can move again to the runnable state, and you can be scheduled for your next time slice, your next CPU time slice. What happens? You run again, so you move again in the running state, and you will eventually terminate your execution, and you will transition to the finished state. That's it, as simple as that.